in 2.8, we're going to combine rational root theorem with other kind of roots because it's just rational that that test works for. Because when we really break down real roots, they can be rational, but they also can be irrational. Now, just so we're clear, imaginary is the form of a plus bi, whereas I really don't like how I write i's on this board. Irrational numbers are the form, like the square root of a positive number. Now be careful, because the positive number, if it's a perfect square, then that falls under the category of a rational root. So what I'm talking about is like the square root of 2 is irrational. So an example given would be root 2, root 3, not root 4, because the square root of 4 is 2, which is rational, but root 5, things like that. So now that we look at h of x, they give you the graph. There's several things to notice about this. First thing, maybe you notice that it's an even degree. That's noticeable from the equation, and the end behavior is the same on both sides. Just a reminder, same end behavior, opposed to being opposite end behavior. Positive leading coefficient would probably be another thing to notice. This is a very open-ended question, by the way, because you might notice something else. And also maybe the fact that it goes through the y-intercept at 0, 9. And that's pretty evident because of if you plugged in 0 for all these x's, you would get 9. Now, as far as the 4 roots based off of the graph, I think it's pretty clear to see that to the right of 0, there are 2 roots. So you can say that there are 2 positive roots. And then also to the left of the origin, there is going to be 2 negative roots. And again, you can do some more investigating based off of things we've already learned, that there are 1, 2 sign changes. So from the Descartes rule of signs, that confirms this. And I'm not going to go through the work to do negative x, but there's at least 2 sign changes. There might be 4. Let's see, that would be positive, positive, negative, negative, positive. So 2 sign changes there as well. On the next one, they talk about using the rational root test. So remember, those are factors of your constant, plus or minus 1, 3, and 9. But then you also have to divide by factors of 3, which we already took care of 1 because all of these numbers, I guess I put positive, negative 9 as well. And now you need to divide by 3, so plus or minus 1/3. And you could try, well, 3/3 reduces to 1, then 9/3 reduces to 3. But just from this list, I would say that negative 1/3 appears to work, and positive 3 appears to work, and the other 2 do not. So we can use synthetic division to test those out. I would start with 3 because I like whole numbers. I don't know how you guys feel. 3, negative 8. Negative 12, 24. There we go. And see if that confirms. 3 times 3 is 9. 1 times 3. Negative 9 times 3. All right, so 3 worked. Now I would do this again with negative 1/3 because my goal is to get this down to a quadratic. which is actually the next question. So bring the 3 down, times negative 1/3 is negative 1, which actually cancels there. Adding straight down, there we go. So this confirms that x equals 3 is a root, and x equals negative 1/3 is a root. And now that we have down to a quadratic, you can do the quadratic formula, although this problem I would not actually spend time doing the quadratic formula because you can just add 9 over and divide by 3. So x squared will equal 3, and then x will equal plus or minus the square root of 3, which is about 1.7. So if I go back to that graph, about 1.7, about negative 1.7. When you get practice with all these numbers, you'll start memorizing irrational numbers. Okay, so here's another one. So as you go through your, I guess, progression of things, so what should not make sense as you look at the graph and this? Well, there's 2 zeros, 2 roots, but I'm supposed to have 4. It's a 4th degree. So what does that mean? That means we better have 2 imaginary roots. Because 2 of them are real, they're accounted for, but the other 2 are not. And that's where you would go through then your possible rational roots, plus or minus 1, 2, and 4. Those are your looking at the constant, but then you also have to divide by other factors of your leading coefficient. So 1/2, you don't have to write down 2 halves because that's 1. You don't have to write down 4 halves because that's 2. And as you look at this, I would say probably need to examine negative 1/2 based off the graph, and probably positive 1. Doesn't look like anything else would even remotely looks like it works. So let's try it with synthetic. So 2, negative 1. I'm trying to squeeze it right here. 7, negative 4, and negative 4. Again, I would probably start with what I perceive would be the easier number. Like I would perceive 1 to be the easier. There you go, so that did work. And then you want to do synthetic just straight down. Hopefully you leave enough room trying the other number. The other number we're going to try is negative 1/2 based off the graph. So we'll switch back to that same color. Let's see, negative 1, 0, 0, 8. There you go. So they both worked. X equals negative 1/2. X equals 1. We've now gotten this down to a quadratic. And you can use the quadratic formula, although in this problem I would probably just, because the b term is 0, you can just add 8 over and divide by 2. So x squared will equal 4. I must have made a mistake. Well, that's an easy mistake to find because it should have been a plus right there, so I should have subtracted 8 over and divided by 2, which is negative 4, and the square root of negative 4 is plus or minus square root of 4 is 2, but then you have an I there to find your remaining roots. And now we have a step-by-step procedure on how to find all roots. Although I hesitate to say a step-by-step procedure because there's a lot of guessing and checking. So here's another function where they ask you to use a graphing calculator to graph it. So I'm just going to pull up the answer key. Otherwise, I imagine you guys can type this into a calculator. You can use Desmos.com to type it in as well. So here is what the graph looks like. Notice that he also added in that y-intercept of negative 10. You might be asked to do that on the homework or on a test. So we can deduce from this that from this graph that we're going to have two real roots, one that's positive, one that's negative. And then two of the roots must be imaginary to satisfy the fundamental theorem of algebra, which is that we need to have four roots for a fourth degree polynomial. And you can even see how he lists out all of the possible roots. It'll also be a task that you're asked to do. Again, I can forgive you if you only write one plus or minus. Now, if you don't write any plus or minus, you will probably lose 1 point on a future test. And feel free to pause the video before I start showing you more work. I hope all of this makes sense. You find factors of 10 for the numerator, factors of 12 for the denominator, and do all of those problems. Okay? And then from that, it's somewhat evident that the best options are negative fractions smaller than 1 and also positive fractions smaller than 1. And this person said, let's go ahead and try negative 1/4 and 2/3. So that's what I'm going to do. So our synthetic will be set up 12, 19, 48, negative 29, and negative 10. And I believe they said negative 1/4 is our highly probable root. Should get a remainder of 0 to prove that that's true. So remember, if you divide by 4 is the same as multiplying by 1/4. So negative 3, adding straight down, divide by 4, divide by 4, I don't know what's wrong with me. There we go. So negative 1/4 worked. And then try, I believe they said 2/3. And remember to multiply by a fraction. You multiply into the numerator, divide by the denominator. So 12 times 2 is 24, divided by 3 is 8. Or you could divide first, like 24 divided by 3 is 8, times 2 would give me 16. And same thing, 60 divided by 3 is 20, times 2 would give me 40. Now we're down to a quadratic. So now we can use a quadratic formula. Now this one, if it's helpful, you might want to factor out a 12 there as well. So x squared plus 2x plus 5 times 12 gives you 60. Now this just makes you doing the quadratic formula easier. You could have done the quadratic formula with negative b, negative 24 plus or minus the square root of 24 squared, except I don't know what 24 squared is. I do, however, know what 2 squared is. 4 minus 4 times 5 is 20, all over 2. So that square root is really negative 16, which is the square root is 4i. So I'm just doing some scratch work. So we're looking at negative 2 plus or minus 4i over 2. And I do expect you to reduce that because both those are divisible by 2. 2 divided by 2 is negative 1, plus or minus 2i. Is your remaining answers. One more important distinction, and I will share with you the answer key, is sometimes at the end you might be asked to write down all of the roots. So again, as I share, you might be tasked with writing down all of the roots, just like this. So I'm going to make one more video finishing these problems, but before I do that, you can pause the video and get all of these down. And here's a step-by-step procedure, but again, there is guessing and checking. And you will be allowed to use a graphing calculator on extremely difficult problems. And then use the quadratic formula after synthetically dividing to get it down to a quadratic.